Here's a math formula magic cube puzzle that I recently got it from friends. Instead of having different colors to differentiate each face like a normal Rubik's cube, this cube has different math equation on it and also had this kind of blue shading on some cubies. And I do have some familiarity in solving the normal cubes using the common C4 method, which solves the cube by first building the cross, then moving on to the first two layers, then the orientation of the last layer, and finally the permutation of the last layer. There are many great tutorials online teaching you how to solve a Rubik's cube, and knowing the beginner's method is enough for solving this cube. Because the cube has the same physical structure as a normal Rubik's cube, we can first approach it by focusing on the centers. Have a quick scan around the cube. You can notice that there are 4 centers with an equal sign of them. And the remaining 2 centers, there are some letters on them. It will be easier to explain by looking at the 2D layout of the cube on a tablet. Here's the layout of the scramble cube and the 6 centers that we explained just now. It will be easier to start with these 2 centers, either of these 2 centers, because they have number or letters on them. So when scanning at the layout, we can see that there's this EP and there is MGH and EC and also MB squared. Let's take a look at this formula that I wrote down so that it will be easier to explain. First, we have this kinetic energy formula, EC equal to half mv squared, and the potential energy formula, EP equal to mgh, and the Einstein's mass energy equivalence equation, E equal to mc squared. We can try work things out on this empty layout. So we will be focusing on this face. Here are the relevant corner pieces, and here are the relevant edge pieces. So let's put in the EC first, and then EC equal to half mv squared. Then let's go for the corner piece, EP, put it below the EC, and the MG edge. So if we look at a middle piece here, we know EP equal to mgh, but how about these equations? So let's take a look again at the formula sheet. We have this angular frequency, W equal to 2 pi f. So here will be an equal sign, and here also will be an equal sign. There are 2 edge pieces that have the exact same features. So which one should go to this slot? We can move forward with the final energy related equation before we come back to this issue later on. So we put the E, mc squared, so we know that here E equal to mc squared, but how about this? This one looks like some formula related to trig identities. So let's take a look at here. We have a triangle, and then we have one angle in here. And we can roughly guess that the meter symbol will be an equal sign. So we have tangent theta equal to CO divided by CA. So tangent theta, the opposite side will be CO, and the adjacent side will be CA. And we can roughly guess that the CO will refer to the opposite side, and the A will refer to the adjacent side. The edge will refer to the hypotenuse. Then we can figure out what are the cosine data and the sine data. So here will be tangent data equal to CO divided by CA, and E equal to MC squared. So now we need to figure out which piece will go to which slot. Okay, so we can take a look at this blue shading, and we can notice a pattern. There's this triangular pattern. So we can roughly guess that this piece will go to this slot, and the remaining piece will go to this slot. And then we have this beautiful triangular pattern. And now we have the first layer solved. We have this face, which is, we can roughly guess that is related to the trigger identities that we walked through just now. And this face will be related to the electromagnetism, as shown here. So we can put the symbols in. We have one of the edge pieces, the cosine theta will be equal to the adjacent side divided by the hypotenuse. And we have the sine theta, the corner piece, equal to the opposite side divided by the hypotenuse. And the curve of E will be equal to negative dB dt, and the divergence of B will be equal to 0, and the curve of H will be equal to J plus d dt. Since we have already kind of like figured out what these two faces are, we can then slowly figure out the remaining three faces as we solve the cube later on. So we can start solving the cube by first looking at the kinetic energy equations. So we have this half with a multiplication sign here, and the mv square, and also the symbol EC. And we can put it in place by first doing U to put it here, and this F prime to put it here, and do a D, and then insert the mv square here, and do a L2 to put it in place. So now we have the kinetic energy equation solved. Looking at the side, we have this plus B, and it makes sense for this plus B to pair up with a center that has letter on it. In this case, it will be the MS, because all the other three centers will have equal sign on them. So to have the MS arranged the same way as the plus B, we can do small u prime, and do an R2, and do a small u to put it back. So we have the MS plus B. So now let's solve the potential energy equations. So we have the EP here, and the MGH right here. So we put the EP down here, and the MGH should be below the MV square. So can do the normal insertion to put in place, and then we have the MV square here. So like this, and then we have this EP and MGH. So finding the equal sign, it will be here. So take this out and try to insert it down here. Can do an slice and U2 and put it back. So we have this EP equal to MGH. E equal to MC square. We have the E here and the MC square here. So putting them in place with this E, and put the E in, back in, and the MC square right here, and just put it in. So we have the E MC square, and the equal sign would be this one. Okay, so put it up and put it in place. So we have this face solved, the first layer solved. Then we start solving this face, the triangle identities, and this one should be cosine theta, and the piece is in here but it's flipped, so we can take it up and then put it back in place correctly. So now there's this cosine theta and tangent theta, tan theta. Cosine theta would be equal to this one, the adjacent side, and then the hypotenuse. So it's also flip. So now we put it back correctly in place. So now for the magnetic related equations, we have this one should be the curve of edge, so this one should be a cross instead of a dot, and the curve of edge should be equal to the j plus with the partial differentiation of the d with respect to time. So putting this in here, so we have this right here, and then we have this sun symbol is equal to the differentiation of the change of d divided by the change in t. So it should be v, that is the velocity. So the final equation of this face should be also related to motion calculations. There is this a, and then we have the change in velocity divided by change in time, so it will be a equal to the delta v divided by delta t. And here we have this a squared plus b squared, and then look around the top layer, we have this c squared. So it should be the Pythagoras theorem, the c squared equal to a squared plus b squared, and then this one should be y equal to ms plus b, the straight line equations. And this one should be the m, the gradient, the m equal to the difference in the y coordinate of 2 points divided by the difference in the s coordinate. So now the bottom two layers are solved, but not quite, because these centers and these centers, the blue shadings are not oriented very correctly. This one is both are 90 degrees off. So what we could do is, by taking this out and then putting it back here, and then insert a random piece in, and then when you put it back in, then this one will be oriented correctly. So same logic will be applied to this center. So now it's fixed. For the orientation of the last layer, we need to identify the symbols that belong to the top face. Since we have already identified the symbols that belong to the other faces, then the remaining pieces that aren't belong to the other faces will belong to the top face. So we know this, and these 5 symbols belong to the other faces. So these remaining 3 edge pieces belong to the top face. But we couldn't really run into this kind of OLL case on a normal Rubik's Cube. So there's something going on here. So this happened because we have these 2 pieces that have same symbols and same shading on both sides. So we can't really sure that whether these 2 pieces are oriented correctly, right? So if we look at a normal Rubik's Cube, and there are 3 possible cases. So for the first case, both pieces are oriented correctly, and for the second case, both pieces are oriented incorrectly. And for the third case, only one of them is flipped. So for the first two cases, when either both of them are oriented correctly or both of them are oriented incorrectly, we can actually solve the cube normally. But for the third case, when only one of them is flipped, then we can run into this impossible OL case, which is the exact same issue that we are facing right now. So we can just flip either one of these pieces to turn it into one of these cases. Then we can solve the cube normally. Okay, so maybe just choose to flip these pieces. And notice that this one is also like we disrupt this piece, so we can just like normally. Okay, so for the OL we have this, and this, and this belong to the top face. So perform the normal OL. Then now we have all the top symbols oriented correctly. So for the PRL, we have these two correctly in place, and then this one needs to go to here, and this piece needs to go to here, and this piece needs to go to here. So it's a clockwise and rotation. And for the edges, this piece needs to go to here, and this piece needs to go to here, and this 0 needs to go to here. So it's a GI permutation. So just apply the PRL algorithm. Only this central piece and this central piece are off by 90 degrees. Other than that, all the other faces are solved correctly. We wouldn't really run into this kind of issue when solving a normal Rubik's Cube, because we couldn't really tell the degree of rotation of the central pieces on a normal Rubik's Cube. So when I first ran into these central pieces alignment issues, the first thought that came to my mind was that I can try spamming certain PRL algorithm to see whether it will affect the rotation of the central pieces. So I have this normal cube, and I use some arrows to indicate the direction of the central pieces. So for example, I can try spamming the T permutations, and another T permutation again to fit it back. And what we can notice is that it actually rotates the top layer, only the top layer central piece by 180 degrees. And then if we perform the U permutation, the clockwise U permutation by 3 times, we can actually have some effect on both of these central pieces. Second time, and the third time. So we can notice that the top central piece rotates by 90 degrees anti-clockwise, and this piece rotates by 90 degrees clockwise. So in our case, we need to rotate this and this both by 90 degrees clockwise. So what we can do is that we can try apply the clockwise permutation 3 times, just like what we did just now. And after applying that, we can fix this alignment issue, but this one will be 180-degree off. So we can then apply the T permutation 2 times to fix the issue. So let's do that. Keep trying. So okay, this one is solved, the alignment issue, and then this one is 180 degrees off. So we can just apply T permutation 2 times. Then we already solve all the faces. That is pretty much it, and thanks so much for watching. Bye.